Hello everyone, you're welcome to this channel once again. Today we have another question from the aerodynamic point of view. Now let's read through the question we have today. The aerodynamic drag of a new sports car is to be predicted by a speed of 50 km per hour at an air temperature of 25 degrees. Automotive engineer built a 1/5 scale model of the car to test in the wind tunnel. It is winter and the wind tunnel is located in an unheated building. The temperature of the wind tunnel air is only 5 degrees. Calculate how fast the engineer should run the wind tunnel in the order to achieve the similarity between the model and the prototype. Given that the density of the prototype is 1.18 kilogram meter cube, the prototype of the density of the model is 1.269 kilogram per meter cube. The viscosity of the air for the prototype is 1.849 10 to negative 5 kilogram meter per second. The viscosity for the model is 1.754 to 10 to negative 5 kilogram meter per second. Today we have this peculiar question from the aerodynamic location telling us that an engineer is running a wind tunnel test for a model car whereby wind is being passed through the chamber, flowing through the model. Now let's approach this question by pulling out all the parameters one by one. Firstly, we have the speed for the prototype to be 50 kilometer per hour. We have the temperature of the air for the prototype, 25 degrees Celsius. We have the size scale for both prototype and the model, LP ln equals 5, or we can say ln over lp equals 1/5. We have the temperature of the air for the model inside the wind tunnel to be 5 degrees. We have the density for the prototype given to be 1.4, 1.1, kilogram per meter cube. We have the density for the model, 1.269 kilogram per meter cube. We have the viscosity for the air for the prototype, which is 1.85. 10 to negative 5. You have the viscosity for the model 1.75 to 10 to negative 5, both in kilogram per meter seconds. Don't let us forget that for aerodynamic similarity tests, while comparing the model to prototype, that we can deduce that the Reynolds number of the model equals to the Reynolds number of the prototype. So therefore, Vm for the model to the density of the model to the size of the model over the viscosity of the model equals V to the prototype to the prototype. Now, by using this particular equation, we can find the velocity for the model, which is Vm. So therefore, Vm equals the velocity of the prototype to the density of the prototype to the size, velocity of the model over viscosity of the model multiplied by Lm to highlight the viscosity of the prototype. Now, if we slot in all the values here, we can deduce that our Vm equals 50 multiplied by 1.184 multiplied by 5, which is the size, multiplied by the viscosity of the air for the model, 1.754 times 10 raised to the power minus 5 all over 1.2691, the size of the model, to 1.849 times 10 to negative 5. So our Vm becomes 2 to 1.27 kilometer per hour. So our calculated velocity for the model inside the wind tunnel becomes 221.27 kilometer per hour. Thank you for staying tuned.